Everyone, let's see what is required of us today. Okay, at this moment, because I'm gonna make a ton of videos. I'll make at least 5 of them today, and it is the 4th of January 2021. Okay, so this is the textbook we're using in case you're watching this for the first time. Another thing you should know is that the grass looks greener on the other side of the fence. Simply put, some things are easy if you take a look at them at a glance, but if you do more than a glance, you get to realize how hard they are. And why am I saying this? I'm saying this because you see, you might find we might think problem solving is easy just because you're watching me doing them right. It's not that easy. And if you really think I'm mistaken, you know what? You should try to do it on your own. I know most of them you might find them easy, but there are some problems out there, not necessarily on methods, but on other chapters as well. Okay, we're talking challenging problems. Okay, so I beg you guys to make sure that not only you watch this video, but you make sure that you try some of these exercises yourself as well. Okay, so that should be it. Okay, so let's get on to the problem on hand here. So a palindromic prime is a prime number and also palindromic. What the heck is that? A palindromic prime is a prime number and also palindromic. Okay, for example, 1 to 1 is a prime. For example, 131 is a prime and also a palindromic prime, as are 313 and 757. Write a program that displays the first 100 palindromic prime numbers. Display 10 numbers per line separated by exactly one space, as follows. Okay, that shouldn't be hard. Okay, before we jump onto coding, you see, this is one thing that I haven't mentioned before. You see, when it comes to programming, you gotta forget about the technology, right? Or perhaps the tools at first. Like, what you wanna do is to have a deeper understanding of the problem on hand. You wanna apply logic to try to break down the problem into its smaller pieces, and then once you get a deeper understanding of what is it that is required of you, you then jump onto your IDE, okay, and then do the coding. So right here, let's talk about the problem. We were told that a palindromic number is a number that is both a prime number and it is also a palindrome. Okay, number one, we do know. Okay, basically what we want to do is to firstly what we want to do is to determine whether or not a number is prime. Okay, and secondly, we wanna determine whether or not a number is palindromic. Is a palindrome. In case both of these conditions are met, then you can conclude, or rather print out that number. Okay, enough words. Let's see the code now. Okay, what I did is I created method bodies, 3 of them. Okay, the display palindromic, which will be invoked by our main method, and the second one is the is prime method, which is also there on the textbook, and the third one is the palindrome method. Okay, there was a tongue twister of some sort. Okay, anyways, okay, so first things first, we wanna take that, wanna copy that and paste it up there. Okay, what we'll then do is to I wanna have count, which will help me display 10 numbers per line. Long, which will be a number to check. Okay, number one, we don't know how many times we wanna iterate, so what we're gonna have to do is to use a count, not a count loop, a while loop. Okay, there's no such thing as a count loop. Okay, however, we will keep continuing as long as count is less than 100. Okay, so if that is the case, we simply check if a number is prime. If it is, it has to be prime and also have to be a palindrome. So is palindrome. Again, I'm passing number here. Palindrome. Did I misspell it? Palindrome. It's P-A, not P-O. Okay, is palindrome. Okay, if these two conditions are met, then we know that. Okay, let me first start by incrementing my count. What I will then do is to check if count mod 10 is exactly 0. If that is indeed the case, then we know we're printing on the current line. Otherwise, in fact, we're printing on the next, we're printing and then go to the next line. God. Okay, why do I find it hard to say that? Okay, we're printing and then go to the next line. We print number. We can simply print and go to the next line. There's no need for me to follow that by space. Okay, system.prints. I print on the current line, and then immediately after that, I've got to leave a space. Okay, they told us to make sure we're leaving exactly one space. Okay, now regardless of whether or not a number is prime, what we want to do is to increment our number. Okay, that should be it for this method. Okay, however, it's not finished in a way that we still have got to implement those two methods. So we're gonna have to start with the is prime method. I don't like copying and pasting solutions that are already there on the textbook, right? So I always like doing things my way. That way I get to learn even more. Okay, again, you will notice that the algorithm they have on the textbook is quite different compared to mine. Okay, so I'll simply go So I'll simply go. Let's check out their example first. Okay, so I will simply go long I. The reason why I'm using the long data type is because we don't know how huge this thing can be. I mean, these numbers can be. So we better play it safe. Perhaps a short would have. Perhaps a short would do it as well. But you know what? I'll go for the long data type. I++. I don't think there's nothing much to explain here. But you know what? I've realized that by making positive assumptions like that on the one I just made, I end up not on the same page with some of you folks out there. Okay, so the better approach will be to presume that you guys are out there don't know a thing. It's better I treat you as if you don't know shit about programming. Okay, excuse my language there. Okay, so return false in case you find the divisor, otherwise it will return true. We're almost there now, folks. Now it is time to check whether a number is palindrome. Again, you should know one thing here. You shouldn't be more concerned about the efficiency and the effectiveness of my program. The point there is I'm demonstrating how method works. It is entirely up to you how you go about implementing them. Again, right here I'm showing the idea. That's all. So that's why you would find me having inefficient solutions just like this one here. There's absolutely no need for me to convert this number to a string to work with string, but I'm doing it anyway. So right here, when I want to have, again, let's talk about the idea of checking whether a number is palindrome. It should read the same when reading it from left to right and right to left. It should read the same. Okay, so I will have the high index and the low index. Basically, the high index will be my index on the right hand side, and the left index will be my index on the left hand side. And initially we're gonna, okay, you'll see this in a moment. There's no need for me to say it. Okay, as you can see, we're initializing high to the last index of our width string, okay, and low will be the index of the first character. High is the index of the last character, and low is the index of the first character, and there is 0. So keep modifying the two variables. We'll keep going. We'll keep going up until the two variables are equal or one is greater than the other. Okay, in which case we will know that that is indeed a palindrome. Again, we keep going as long as the two corresponding characters are exactly the same. So while high is greater than low, if the character, if word dot char at low is exactly, if it is not equals to word, oh, why can I type now, word dot character at high, if it is not the same, then we know that this is not a palindrome. So we will immediately return false. Regardless of what we did, we've got to modify high with incrementing high, because we going from on the from the high. Okay, from high's point of view, okay, from the variable high's point of view, we're going from right to left, and we're going from left to right from low's point of view, okay. Okay, so that's why we've got to increment low and decrement higher. What else we wanna do? Absolutely nothing. Okay, so it seems like now we have a completed solution. So let's hit run and see what we get. Oh, there we go. Okay, as you can see, these are our numbers. These are our numbers right here. Okay. Did I mess up? The second line ends with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 6, 7, 8, 9, 10. I wonder why we have different numbers. 191 followed by 313 followed by 353 373 8 383 727 756 787. How many numbers do they have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then why am I having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wow. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 101. Is 121 not a prime number? You know what? I know this won't help. In fact, this doesn't make any difference, but I'm doing it anyways. It seems like I've included some numbers here which shouldn't be here. But you know what? Oh, let's inclusively. It was because of that, I bet. I swear. It was because of that. Boom, we've got it now. For a moment, you know the reason why we had numbers such as 121, the reason why we had numbers that shouldn't be here was because of the fact that I forgot including. We're going all the way up to number over 2 inclusively. Again, this will also work even if we use math.square root just like before. Oops. I know I'm probably wasting time now, but then just trying to show you guys that our previous solution was okay. It is just that I forgot this. You see, it works. This equal sign there to include the number that will end with. Okay, that should be it, you guys. See you on the next solution.